So let's look at the example that we were looking at the end last time. We had x cubed plus y cubed is equal to 6xy, and we found dy dx to be given by 2y minus x squared over y squared minus 2x, and let's say you are asked to find the equation of the tangent line at the point 3, 3. So you're told that the point 3, 3 lies on the graph of the given equation. You need to find the equation of the tangent line there. So how would you find that? Well, you need the slope of the tangent line, which will be given by the value of the derivative at that point. So what's the value of the derivative at this point 3, 3? Well, the value of the derivative at the point 3, 3 is given by what? 2 times 3 minus 3 squared over 3 squared minus 2 times 3, and that is negative 1. So what's the equation of the tangent line? Y minus what? 3 equals to negative 1 times x minus 3, and you can simplify it a little bit by multiplying out on the right hand side, but that's the equation of the tangent line. Is everybody okay with that? Alright, so that's the equation of the tangent line, and you might see you will see similar questions in your homework. You'll be given an equation, you'll be asked to find the equation of the tangent line at a given point on the graph of that equation. Is everybody okay with that? Okay, let's look at a different example. Let's say we have the following equation: root of xy equals to 1 plus x squared y. And again, I have to find the derivative of y with respect to x. And how would I find it? Well, first of all, the left hand side simply is xy to the half, and then we take the derivative of both sides with respect to x. So I take the derivative with respect to x here. I take the derivative with respect to x, which would be 1 plus x squared y. And okay, so what's the derivative on the left hand side? What did I get? Say it again. Okay, so in other words, you're saying, okay, I have xy to the half. I am differentiating with respect to x. So when you look at xy to the half, you would hope that you had only x, right? So if I have just x to the half, then the derivative would be half of x to the half minus 1. and inside here I am going to have what? xy. And then multiply by the derivative of the quantity that you wished was just x. And here the derivative of 1 is 0 plus the derivative of x squared times y, right? So you have to view this as the product of the function y and the function x squared. So you have to apply the product rule. So if I have to apply the product rule, what's the derivative of x squared y? What's the derivative of x squared y? Derivative of the first factor is what? 2x multiplied by the second factor as it is, plus the first factor as it is multiplied by the derivative of the second factor, which is just dy dx. And now I can say that I have half xy to the negative half, and here the derivative is what? Again, I have to apply the product rule. I have x times y, so the derivative of the first factor is 1 times y plus the first factor times the derivative of the second factor. So that's what I have. Here I have 2xy plus x squared dy dx. Is everybody okay so far? Now, we are done with calculus. We have taken derivative completely. However, we need to come up with dy dx. So we have to solve for dy dx now. And solving for dy dx is just algebra now. So what should I do to solve for dy dx? There are a couple of different ways you can go about, but I think the one nice thing you could do right away is multiply both sides by 2 and also multiply both sides by xy to the power positive half. So if I multiply both sides by xy to the positive half, it's going to cancel out this term here, right? So multiply both sides by 2 and xy to the half. If I do that, then on the right hand side I am just going to get y plus x dy dx. On the right hand side, when I'm multiplying by 2, right, so I'm going to get a 4, and I have 4xy already there, and I will also multiply that by xy to the positive half. And then the x squared here would be 2 times x squared times xy to the half, and I have dy dx. You guys agree with that? I multiplied each term by 2 and xy to the half, right? Everybody's okay with that? Alright, so now let's simplify a little bit. You get y plus x times dy dx. Notice that I have, when I have x times x to the half here, right? So what is x times x to the half? So I could write this expression as x to the what? 3/2. And also y to the 3/2 in a similar way, plus in the second term I can combine x squared with x to the half, which would be what? X to the 5/2, and then I also have y to the half dy dx. Notice, in order to solve for dy dx now, what I have to do is basically I have to combine these two terms on the left hand side, and then and I have to combine these two terms on the right hand side, right? So let's do that. what I would have is x dy dx minus 2x to the 5 half y to the half dy dx, which is equal to 4x to the 3 half y to the 3 half minus y. Is everybody okay with that? Next, what should I do? Factor out dy dx, so I get 2 times x to the 5 half y to the half dy dx, which is 4x to the 3 half y to the 3 half minus y. Okay? And finally, dy dx is 4x to the 3 half y to the 3 half minus y over x minus 2x to the 5 half y to the half. Is everybody okay with that? So that's the final answer. Any questions, anybody? Okay, I am going to maybe do one more example here. Let's say I have the equation, let me see, let me try to come up with something simpler. Well, let me just use the simplest example that we have done so far. Remember how we found dy dx? We differentiate both sides with respect to x. We get what? 2x plus 2y times dy dx is equal to 0, and then dy dx is what? Negative x divided by y, right? We did that before. I'm not showing you all the details. But you can solve for dy dx and you get negative x over y. Now let's say you're asked to find the second derivative of y with respect to x. So how would you find the second derivative of y with respect to x? Well, the second derivative is what? It's the derivative of the derivative function, right? So the derivative is given by negative x over y, right? That's what the derivative is. So you have to take the derivative of that. So how would you take that derivative? The denominator y is a function of x, and the numerator is a function of x. So quotient rule says I get what? Y squared here. I'm going to get a you know what? I am going to write it as negative derivative of x over y. Is that okay? I can factor out that negative sign. So this negative sign, I'm going to put it right here. Just so you can see it, I'll put it in green. Oops. Okay, so what goes here? Well, it'll be denominator times the derivative of the numerator is what? The derivative of the numerator in this case, I'm looking right here, 1, and minus x times what? X times what? It'll be the derivative of the denominator, which is what? Dy dx, right? which should be dy dx. So what am I getting? I'm getting minus y minus x. What is dy dx? Remember what was dy dx? It was negative x over y, right? So I'll plug that in. And what am I getting then? Minus y plus x squared over y divided by y squared. How would you simplify this? Well, one trick is to do what? Multiply and divide by the common denominator of all the denominators. So I multiply and divide by y. And if I do that, what am I getting? I'm getting negative y squared. The negative is in front of the fraction, sorry. Okay, so y squared plus what? X squared divided by y cubed, and I have a negative sign in front. Is everybody okay? So that's the second derivative. Any questions at all? Okay, so we are done with 2.6, but I plan to do more examples tomorrow from 2.6, but I want to go ahead and start 2.8 today and at least go over our two problems from 2.8, okay? So section 2.8 is about what we call related rates. So related rates. So this section has applied-oriented problems, application-oriented problems. Basically, these are word problems, and these are applications of implicit differentiation. And what happens usually in these problems is the following. You know that you have this artifacts requirement. You have to have turn in something like 10, 12 artifacts, right? And this class, you also get a chance to have an artifact. So I'll be giving you an artifact pretty soon, and the artifact is related to this related rates. Okay, so you have this extra motivation of going over these problems if you want to make sure your artifact looks nice. Okay, so I'll give you an artifact sometime toward the end of next week. Okay, or maybe not. Yeah, I have to probably I'll let you know clearly on Monday when I'm going to give you the artifact, but I'll let you know ahead of time. Related rates. Usually, what happens? These problems usually looks like the following. Usually, in these problems, you have certain. Usually you have three quantities, okay? And the three quantities, let's say, denote them by three variables: x, y, and t. So usually in all the problems in related rates, you have three quantities, and let me call them, let me denote them by the variables x, y, and t. Usually t represents for time. T is time. So usually one of the variables is time. Now, in all these questions, you will be given the rate of one of the variables. So you'll be given. You will be given the rate of x. So the rate of x means is the rate of change of x with respect to time, which is the derivative of x with respect to time. So usually you are given one of the rates. You need to find the rate of the other variable. So you have to find dy dt. Am I making sense? So usually you have 3 variables in most of these problems, and you will be given the rate of one of them, and you have to find the rate of the other. Am I making sense? Usually the third variable is time. And so how would you do it? The idea is that somehow you have to come up with an equation involving x and y. So to solve these problems, is my question clear? 3 quantities, 3 variables, x, y, and t. Usually t is time. You will be given the rate of x, you have to find the rate of y. Okay? Now, in a specific question, you might not label your variables by x and y. Maybe you're going to use a and b or something else, but I'm just taking x and y. And usually how would you solve them? Well, what you have to do is, so how would you solve this? How would you solve this type of problems? Well, your goal should be to find an equation involving x and y. If you can find an equation involving x and y, then what you could do is you can differentiate both sides of the equation with respect to time. So then you can differentiate both sides with respect to time, and once you do that, what you're going to end up with is you're going to end up with another equation, and that equation will involve the variables x and y, and also the rate of x and the rate of y. So if you take the derivative of both sides, then you're going to end up with an equation, and the equation will involve the rate of x, the rate of y, x and y, right? And then you are in business, because what? The question will give you the rate of x. Your goal is to find the rate of y, right? So you just plug in what is given, and then you solve for dy dt. Is that making sense? You're given the rate of x, you have to find the rate of y, and your strategy is find an equation involving x and y, and then differentiate with respect to t, and that's going to give you an equation involving the rate of x and rate of y. If you have an equation involving rate of x and rate of y, you can plug in the rate of x and then solve for the rate of y. That's the strategy. And so this will be demonstrated in the examples that we're going to do next. So my first example, by the way, these are from section 2a. We are skipping, unfortunately, section 2.7. Okay. All right. So what's the example here? Here's the statement of the problem. A 10 feet ladder rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 feet per second, how fast is the top of the letter? How fast is the top of the letter sliding down? How fast is the top of the letter sliding down the wall? When the letter is 6 feet from the wall. Okay, so let's read the question again. So you have a 10 feet ladder which is resting against a wall. The bottom of the ladder is sliding away at the rate of 1 feet per second, and we want to know how fast is the top of the ladder sliding down at the moment when the bottom of the ladder is 6 feet away from the wall. Is the statement clear to you? Now, whenever you have problems like this, you have to read the question a couple of times to make sure you understand what is given in the question and what is being asked. And it is helpful to draw some diagrams. So let's say that this is the floor, and let's say this is the wall, and let's say the ladder is given by this. Okay, so the ladder is 10 feet long. The ladder is 10 feet long, and this is the bottom of the ladder. This is the top of the ladder. What rate is given? The rate at which the bottom of the ladder is sliding away, right? And so that means we are looking at the rate of change of position of the bottom of the ladder, right? And so that rate that is given. I can express it as the derivative of what variable? What's that? Okay, what should x represent here? Well, notice that if x is the distance of the bottom of the ladder from the wall, then the rate of change of x is the rate at which the bottom is sliding away, right? So what is and let's label the height of the top of the ladder by y. So let's think about what is given in the question. What is given is that the rate of x means is the derivative of x with respect to time. The rate of change of x with respect to time. And that is given to be what? 1 feet per second. 1 feet per second. And okay, and what do we have to find? What do we have to find? We have to find the rate of y, right? The rate of change of y with respect to time. At what moment? at the moment when x becomes 6. Right at that moment, what's the rate? Okay. Now the rate of x is constant here. The rate of x at any moment is the same. Okay. So okay, now I have to find the rate of. So again, you see, remember 3 variables x, y, and t. You are given the rate of x. You have to find the rate of y. So what is your strategy? Well, the strategy would be to find an equation involving x and y. And well, someone already has an answer that by looking at the diagram. This is why you should make a diagram, because once you make the diagram, it's pretty clear what to do. I can easily come up with an equation involving x and y, which is x squared plus y squared is equal to 100, right? That's by the by the Pythagorean theorem. Okay, once I have this, then what do? I differentiate both sides with respect to time. So if I differentiate both sides with respect to time, what's the derivative of 100? 0. And okay, what's the derivative of x squared? With respect to time, not with respect to x, right? Yeah, it would be 2x times dx dt. Plus, what's the derivative of y squared with respect to time? 2y dy dt. So remember what I said, once you differentiate, you're going to get an equation involving the rates, which should make you happy now, because you are given the rate of x, so you can plug that in and solve for the rate of y. But there is a slight problem here. So let's first of all solve for, we need to find dy dt, so let's just solve for it. So what is dy dt then? Dy dt is going to be what? Negative 2x. You know what? Let me just write 2y here, and then negative 2x dx dt, and then one more line where I can write down what dy dt is, which would be negative x over y dx over dt. You guys agree with that? So we know the dy dt is this. Now we need to find the dy dt at what moment? Yeah, so we have to find dy dt at the moment. So we need to find dy dt at the moment when x is 6. So I need to evaluate the right hand side then. I need to evaluate the right hand side at the moment when x is 6, right? Now the question is, when x is 6, what is y? Very good. So notice that we go back to our diagram. If at some moment x becomes 8, sorry, not 8, 6. If at some moment x becomes 6, by using the Pythagoras theorem, what would be y? Well, it will be square of 10 minus the square of 6, and then you take the square root, right? So y would be exactly 8. 100 minus 36, that's 64. Root of 64 is 8. So now we can just plug in. So we know that this would be equal to negative 6 over 8 times 1, because the rate of x is 1. And what is that equal to? Well, that is negative 3/4, right? And what's the unit for the rate? Feet per second. Does the negative sign make sense to you? The top of the letter is sliding down, so that means the quantity y is decreasing. So it makes sense to have negative. because because it's decreasing. Y is decreasing. Is everybody okay? Any questions? Everybody's okay with that problem? Okay, so let's look at another example. This time you have a rocket is launched. A rocket is launched vertically upward from a point 2 miles west of an observer's 2 miles west of an observer on the ground. Okay, the question is, what is the speed of the rocket? What is the speed of the rocket when the angle of elevation of the observer's line of sight to the rocket is 50 degrees and is increasing at 5 degrees per second. Is the question clear? So you have a rocket which is going up. There is an observer 2 miles west of that location, and you're given. So you're asked what is the speed of the rocket at the moment when the angle of elevation becomes 50 degrees, and when the angle of elevation is increasing at a rate of 5 degrees per second. This is not a constant rate. We are given that this is the rate of change of the angle of elevation at that moment when the angle is 50 degrees. Okay? So once again, you have to read it a couple of times, understand what is being asked, and make some diagrams, if you can, to understand the problem better. So we are going to do that. So what we have a launch location, let's say right here, and we have let's say this is the ground. Okay, so somewhere on the ground you have the observer. Go ahead and see if you can draw the diagram. Okay, so let's say that the observer is right here. Okay, so here is the observer, and here is the location of the here is the location of the so here is the location of the rocket, which looks like a diamond, I guess, or a rectangle, I guess. And so let's say let's label some of this. What is the angle of elevation here? Right here. Let's call that theta. So as the rocket is going up, the angle of elevation is becoming larger, and let's label the height of the rocket by h. Okay, so let's think about what is given in the question. In the question we are given the following. Which rate is given? That the angle of elevation is increasing at a rate of 5 degrees per second, which means is the rate of change of theta with respect to time, which means this is d theta dt. So the derivative of theta, the rate of theta, is given at what moment? At the moment when theta is 50 degrees, right at that moment, the rate of theta is 5 degrees per second. And what do we have to find? What do we have to find? We have to find the speed of the rocket, which means the rate of change of height of the rocket, and the rate of change of the height of the rocket, and we need to find that rate at the moment when theta is 50 degrees. So what is this quantity at that moment? Is the question clear to you? You have to find the rate of h given the rate of theta. All right. Again, what would be our goal? Well, our goal would be to come up with an equation involving the two quantities, right? Theta and h. Can someone give me an equation involving h and theta? This is 2 miles. Yes, this is 2 miles. Very good. Yes. Yeah, so hold on a second. So remember, for theta, what is h? H is the opposite, right? And 2 miles, that's the adjacent, right? So basically, you should say that tangent of theta is the opposite h over the adjacent 2, right? So it's not sine or cosine involves the hypotenuse, right? Okay, so then from here, what do you get for h? You get h is what? 2 times tangent of theta. Okay, so then what's the derivative of h with respect to time? Well, that would be the same as the derivative with respect to time of 2 times tangent of theta, right? Well, what is the derivative of 2 times tangent of theta? This would be 2 times, what's the derivative of tangent theta with respect to theta? Secant squared theta, right? And then you have to multiply by what? The derivative of theta with respect to time. And so now we could say then the rate of h with respect to time at the moment when theta is 50 degrees, but we have to convert 50 degrees to radians. Why do I have to convert? Well, I didn't emphasize this before. In calculus, the measure of an angle is always in radians. Why? If you don't take the radian measure of an angle, the derivative formulas for the trig functions will not work. Am I making sense? If you take the degree measure, then the derivative formulas for the trig functions will look different. You might say, so remember when I computed the derivative of the trig functions, one of the limits that I used was the limit of sine theta over theta, and we showed that the limit of sine theta over theta is 1, right? If you look at the justification for that limit, remember that we looked at the area of a sector of the circle when we did that, and we used a formula for that, right? And that formula only works when you use radian measure. Okay? So just keep in mind that in calculus you just use radian measure. So here, the 50 degrees that I have to convert it to radian measure, and the radian measure of that is what? You multiply by pi over 180, right? And so I need to know the value of the right hand side. I need to know the value of the right hand side at the moment when theta is 50 degrees. And well, I have to just plug in. So this is equal to what? 2 times secant of 50 pi over 180, and then you have to square that, and then the rate of theta at that moment is given to be 5 degrees per second, right? And 5 degrees in radian would be 5 pi over 180. Okay, you do the math in your head and you come up with what? 0.422 miles per second. Well, okay, you don't do it in your head. You use your calculator to do it. In the exam, because you won't have the calculator, you can leave your answer in terms of a fraction and involving pi. Am I making sense? So you can leave your answer right here, okay? If you have no calculator in the exam. Is everybody okay with that example? Yes. 5 pi over 180?
Yeah.
Yeah, because the rate of theta is 5 degrees per second. So 5 degrees in radians is that. Yeah. All right, I'll see you tomorrow. Remember the quiz 2.4 and 2.5 tomorrow. And please go ahead, start your homeworks from section 2.6 and 2.8.
Do a grade check for me.
Yeah, I can do that. Do you have a pen?
I do. Yes.